Welcome to the Oxygen Alliance YouTube channel, where we bring you videos and installation, maintenance, and various trainings on oxygen equipment and devices. If you have comments and or questions, drop them in the comment section below or write to us info@oxygenalliance.org. Remember to like our videos, subscribe to our channel, and hit the notification bell.
And also your location. When you're typing your name, you can also say, I'm joining from Kenya, I'm joining from Rwanda. I would like to know where you're joining us from. And also, in case you want to get notifications from the Oxygen Alliance, please try your best to just type your email in the chat so that we can also reach out to you and also give you the events that the Oxygen Alliance will be having, as well as the webinars that are coming ahead. Please, 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 please don't forget to do that. So without wasting much of your time, for today we'll be looking at the maintenance of operating theater tables. Specifically, we'll be looking at electro-hydraulic ones. And like I've said, for today, our presenter is going to be Engineer Daniel Muthama, who is based in Kenya. He is a biomedical engineer for Kisumu County Referral Hospital. So please don't forget to have something to write on in case you want to ask him questions. You're free to do so. Without wasting much of the time, over to you, Engineer Daniel.
We are going to cover electro-hydraulic theater tables, and we have our outline. We are going to start with the introduction, the operating theater table functions, the main parts, the accessing the internal components, servicing the major components, troubleshooting the common fault, operating theater table safety, especially the user and technical safety, and then decommissioning. The operating theater table is used in different areas within the hospital. It is used within the theater, the maternity, eye department. You'll find that in these areas we'll be using the operating theater table. It is used for surgical procedures as it provides precise positioning and stability of patients during surgery. And the material making the frame is usually stainless steel of gauge 3 or 4. It combines electric and hydraulic systems to provide positioning and stability for patients during surgery. Here we can see the operating theater table functions. We have height adjustment. The doctor can lower the height, he can increase the height depending on the comfortable position it can be. We have up or down movement. That is what we are calling the pendulum back or reverse movement of the chair. We have the lateral tilt. It can either be to the left or to the right. Are you tilting the chair to the left? Are you tilting it to the right? You can adjust the leg, or you can adjust the head. So these are the various positions the chair can be able to move. Here we'll be able to see the external parts of the chair. We start with the base of the chair. We have the control panel. You can be able to adjust the chair through here. We have the leg supports. We have the right side. We have the left side. These are the leg supports. We have the leg support plus the plate. We have the remote controller is here, and you can see it's placed. It's held within the frame, one of the rails of the operating theater table. We have the arm plate. We have the head plate. These are the positions of the operating theater table where they are marked. The engineer has to know which area is this, which area is this. You have the shoulder support. You want to support the shoulder. We are using that. You have the anesthesia bracket. You can see it's here. And then generally, this is where the patient will be able to be placed on top. And then all of this, and this other one is the frame. Down here, you can see the casters. These casters are movable casters. The operating theater table has different sections, and we are going to start with the mechanical structure. Within that mechanical structure, we have the top, the table top. We have the base column and the frame, as you can see. We have the leg and the foot connections. we have the actuators. We'll be able to see the inside of the chair. You'll be able to see the actuators, what we are calling another name for actuators in the cylinders, the hydraulic cylinders that move the table sections based on the set fluid pressure. We have the hydraulic reservoir, which stores the hydraulic fluid. We have the tubings, we have the lock pins, and we have the solenoid valve housing. Remember that the solenoid valve housing is made of brass. So this solenoid valve is also part of the mechanical structure. We have the lock nuts. These lock nuts are put within the solenoid valve. And then we have the locking bolt. The screw, it's either the flat, it's either the screw type. That's what we are calling the locking bolts. If an engineer wants to service or repair the operating theater table, what are the required tools? You need to have a set of star or flat screwdrivers. In the picture here, you are able to have a set of screwdrivers, whether flat, whether star, and that means small, medium, and flat. You need also to have a set of combination spanners, especially numbers 10 to 27. That means number 10, number 11, number 12, 12, 13, 14, 15, 16, 17, up to 27. But in this case, when we are using our chair, we'll be able to see, you can use number 12, 13, 14, and number 24. This can be combination spanner, or can be open spanner. We have the Allen key set. In this operating theater table, we are mostly using 5.5 millimeter of the Allen key, or you are using 4.0 millimeter of the Allen key. Metric. In the Allen key set, sometimes you can have a metric Allen key, you can have imperial Allen key set. So depending on the manufacturer, the engineer needs to know what kind of an Allen key set are you going to use. We have what we call the pin driver set. We had seen what we call the lock nut, the lock pin. For you to be able to remove that lock pin, you need to use what we call the pin driver. Set means is a combination of several pin drivers. So that's why we are referring it to as a set. We have what we call the circuit pliers. In the picture here, these are the circuit pliers. And the circuit pliers, they can be either small, medium, or large. The Allen key, they are here. We have the first tester. We have the hammer. When you are driving out the pin using the lock nut pin, using the pin, you need to knock it out using the hammer. That's why the hammer is placed here. You need to have a pliers. Maybe you would want to tighten somewhere. You need to have a soldering iron. Maybe you would want to solder some electronic components. You need to remove some of the electronic components. You need to have what we call the solder circle. Don't forget to include the soldering iron stand when you want to place, when you are not working the soldering iron. We need to have the brush. The brush is here. The brush will be meant to remove the dust in the chair, as you'll be seeing. So these are some of the most important tools the engineer must have. What are the materials required if the engineer would want to service, would want to repair the operating theater table? We need to have a gauze, and remember that the gauze is a bit rough. This will be able for the stains to be able to be removed. That's why we are using gauze, not ordinary cotton clothing. That's why we are using the gauze. When you are using the gauze, you need to have to use alcohol 70% to be able to disinfect that operating theater table. At the same time, you must put on the clean gloves. After the clean gloves, you cut the gauze into small pieces using the scissors. And then after that, you apply the 70%, and then you clean out, you disinfect the whole chair. You need to have the cable ties. The work of the cable ties, you can have small, medium sizes. This is to ensure the electrical cables, they are placed in place. They are held in place. You need to have a solder wire in case you are soldering back a component. You need to have a Teflon tape. What is the work of the Teflon tape? You need to check where you have the leakages. You want to see the leakages, then you need to apply this tape within the joints. When you would want to clean the electronics, you are going to use what we call the electronic contact cleaner. These are the cable ties. These are the gloves, clean gloves. This is the Teflon tape. These are cable ties. You can have small, medium, and large. This is emery paper. This is alcohol. This is electronic contact cleaner. And this is instant spray paint. We will see that as we shall be seeing the operating theater table. You need to have a set of fuses, different fuses, depending the current. You need, as an engineer, you need to carry several fuses. You need to have the electronic boards. This operating theater table has two electronic boards. We have the main printed circuit board, and we have the power. Here we are accessing the internal components. If you would want to service the chair, you can see here, maybe it's not quite clear, but here we are able to see the inside part. We are removing the top covers. After you have removed the top covers, you need to disinfect these areas. These areas, you need to disinfect them. Even here, you will find it is dusty, very dusty. You need to clean out this dust. And then the third picture is still the same like this. This one, we are able to see the inside part. This cover, it has 4 star bolts. So you open one here, you open another one here, also the other side. There are 4. Once you remove, there is 1, there is 2, the other side the same. Once you have removed the 4 star bolt, then this cover, you lift it up. Once you lift it up, now you'll be the internal parts. So here we are accessing the internal parts of the chair. We are trying to remove the covers. As an engineer, these covers, when you are removing these covers, there is a screw here, there is another screw here. So once you open this screw, you open this screw. Also at the right side, you do the same. Then you pull out this cover towards that direction, the outward direction. Inside here, you will find there are other 2 plates, of which you'll do the same. They are locked here, the same. So you'll do the same procedure. Once you have removed for this side, you'll also remove for the other side. Once you have done that, and this picture is being followed by that, the explanation I'm giving, here you have been able to access the inside, same explanation. So here we are able to see the internal parts of the chair. Once you have removed those covers, now the covers at the downside, you open them and then you remove. Then you'll be left by the internal parts of this chair like this. What contains the electro-hydraulic system? It contains an hydraulic pump, which is powered by electricity motor to pressurize the fluid within the tubings. We have the control valves. We would want to allow the hydraulic fluid to flow in one direction. So that's why we have the line valves to control the fluid flow. And that when you are controlling that fluid flow, we have the actuators or the cylinders. These are hydraulic cylinders that move the table sections based on the fluid pressure. We have the hydraulic reservoir. That is the tank. The tank is here. This is the reservoir. This is the electric motor. We have the electronics. There is the main board here, and the power board is here. The electronics. These are the tubings. The tubings are here. You can see here there is a cover. This is a rubber which has been placed here, and these are 4. There's one here, there's one here, and also the other side there are 2. This will be able to hold the cover in position. We have the hydraulic reservoir, as I've shown you. We have the control panel or the remote, and we have the tubings. In other words, what makes the electro-hydraulic system? These are the parts which makes the hydraulic system. We have another section which we call the electrical components. You can see here the solenoid valve. These are the solenoid valves. And then you can count them. There is 1, there is 2, there is 3, there is 4, there is 5, there is 6. Once you open those covers, you'll be able to see the solenoid valves. And we say this solenoid valve is both mechanical and at the same time it is electrical gadget. It's supplied by power. So once you open the internal part, this is how your OTT will look like. It's very dirty. It's very dirty. So here we have the batteries. The batteries are 2. There are some operating theater table who will be able to use the batteries. Others are not using the batteries. In case you are using the batteries, then you need to be checking the current rating of this battery is very important for the engineer if you would want to replace. So what are the electrical components for this chair? We have the power cord, which is supplying the power to the chair. And you can see the distance in meters, the length in meters, it is 3 meters. We have the main switch. This main switch is a push button switch. We have the batteries who will be able to provide 24 volts for a power backup. In case there is no electricity, the chair should not be interrupted. We have the sensors, and these sensors, once it senses, it gives what we call a feedback mechanism. And remember in class, you studied about what we call the open and the closed loop systems for the position control, how the sensors are working. It's just a short explanation here. This is the main power board. And this main power board within the operating theater table, it will rarely go faulty. Because remember, it is supplying 240 volts and is supplying to another main board with different voltages. So it is very important to understand these components for easy troubleshooting in the case of any fault. So as an engineer, this is the second electronic board, and this second electronic board, it is the mostly board which will go faulty. And what will go faulty within this electronic board is the MOSFETs. These are the MOSFETs. You can count them depending with the operations of the chair. You can count them here. And these ones here are what we call the optocouplers. If in case one of your MOSFET is not working, you are not able to attain the movement of the chair, you need to check any of these MOSFETs, any change of color. You'll find either one of these or one of these, it has changed color. That change of that color, is it brown? Is it white? That change of color, it means that MOSFET is not working. You also need to check at the other side if there is any dry joints. So once you find that MOSFET is not working, you detach it from the board and then you solder a new MOSFET. And at this particular time, you must follow the part number of that particular MOSFET. The optocouplers will also be matching with the kind of the MOSFET you are working with it here. These are the optocouplers. Not everything within the electronics will go bad. Like in this PCB board, the most probable components, electronic components to be faulty is these two. Here, I've just indicated, here my operating theater table was not working. So in this, you can see this handwritten information. It has different diodes. So we have diode 1, diode 2, up to diode that one. When you click, let's say you want the chair to go upward, it means you'll have this diode and this diode working. If you want another particular movement, you'll have this diode working and this particular diode working. So here, you will find that in this, like in case of my operating theater table, I had 4 movements who are working, but other 4 movements were not working. So here I would identify which diode and which diode is not working. And at this particular point, you need to compare this with a working chair. You compare whatever is working and whatever is not working. Once you have known the particular areas who are not working, then it means there is a particular voltage which is missing. Is it 5 volts? It is 7 volts. And then you check within your electronics that supply. Once you attain that 7 volts or 5 volts to these particular diodes, then you'll achieve the other remaining 4 movements of that chair. So this was just from my practical experience. So I had to come up with such kind of a drawing. This is the solenoid valves. You can see how they are serviced. It's a short, or maybe you can, using a star screwdriver, medium, open that screw anti-clockwise. Once you open it anti-clockwise, lift the body of the solenoid valve. Once you lift that body of the solenoid valve, you clean this frame here. You clean the shaft. You clean the shaft. After you clean the shaft, you also clean the body inside. You get emery paper, number 0 or 01, and you run it through the body. Then after you have cleaned it using the emery paper, you get gauze and run through that the solenoid valve, and you also wipe clean this shaft. At that time, you are using the gauze plus electronic contact cleaner, and then now you clean here and you clean the inside of the solenoid valve. But one safety required here, you should never leave that solenoid valve powered. You are just reassembling the solenoid valve. You reassemble it and then test. What are some of the operating theater table fault you are going to see, or you are going to get, or some of your engineers you have experienced? There is no power. What happens if there is no supply? You need to check the outside cutout. That these are the cutout which is written 60 amperes, 80 amperes, which are outside the building. If you find those, sometimes they are stolen. These cutouts are stolen. And if it means that these cutouts are stolen, it means there is completely no power to the building. So as an engineer, you need to make sure they can burn out. They can burn out. They can have loose connections. So here, they can have a blown fuse. So this is very important for the engineer to make sure you understand the cutout fuses are intact and they are working. If you find the cutout fuses are okay, then you need to check the socket outlet. The socket outlet is there, but there is no output within the socket outlet, power within the socket outlet. You need to measure using the multimeter. If you find any of these is not working, you replace. The socket outlet you replace. Maybe there are loose electrical connections behind the socket. You need to tighten those wires. After the socket, you need to protect your operating theater table with an automatic voltage switcher. And you can see the current. The current is very important. Once you get the inside, it has to show. And also, you also need to get the outlet. The power can get in, but there is no output. So this ABS, it will be able to protect your operating, the electronic components we have seen, the PCB boards we have seen. This is very important. If this ABS is installed and it's not working, you are required to replace it. Do you have any blown fuses within the chair? Is it at the top plug? Is it within the ABS? You need to check and replace. If the push button is not working, does it have dry joints? Does it have loose electrical connections? The push button itself is not working. So you can check and replace if it's not working. And the most important, as an engineer, you are required to replace using the same current. I know here, once this push button is not working, let's say this was 15 amperes, which was installed. When you are replacing, you replace with 10 amperes. It means this push button will not be able to work. It will burn. So you must replace with the same current. The faulty remote, you replace. And before you say the remote is faulty, make sure the batteries are intact. Make sure the terminals for the batteries are clean. Make sure you have used the right batteries. We have the fault we have the fault, but if there is a continuation of the batteries, they are faulty. What will you tell yourself the batteries are faulty? Number one, you need to check any signs of leakage. And you can see this place is dry, but here it shows some wetness. So that is leakage. If there is any leakage, replace that battery. If you check the battery the way it is, you can see this line is very straight, this line is very straight, but here you can see there is some change of shape. If you find the battery has changed shape, then it means that battery requires to be changed, however new it is. If any of the batteries, the terminals are disconnected, they are broken, this terminal is broken, you don't need to connect the wire anyhowly, you need to replace the whole battery. And one trick with these batteries, when you are replacing these batteries, they must be replaced two at the same time. You don't replace one battery, then you leave the other, because there will be difference in voltage and the output current. So the replacement of these batteries must be the same. The worn-out batteries, as an engineer, you need to measure the output voltage. If you find the voltage is low and it is, the chair should be connected, and when through power, and when it is connected through power, it means at that time the batteries are being charged. But if you find that the batteries cannot contain the charge, once you switch off the power, you are not able to raise the chair or you lower the chair, it means your batteries are not working. So we require them to be replaced. Next. There is what we call intermittent movement. The chair moves, it moves, then it stops, or there is no movement at all. You need first of all to check the batteries. And if you find the batteries are okay, are there any loose electrical wires? These loose electrical wires will also bring what we call the intermittent movement. It's very important for the engineer. You also, is the chair coming on and off? You need to check the loose electrical wires and you tighten. As the remote failed, check the remote, replace the batteries, tighten any loose electrical wires within the remote. You can see here, this was my operating theater table, or whatever you are seeing here is the dust. And remember that in electronics, dust will conduct here. And that will produce what we call the electrical sparks. Once it produces those electrical sparks, the electronic components will short. And that short circuit will make sure this PCB board gets burned, or there is no production of the required voltages. So at every, is it between 4 months or after every 6 months, the operating theater table must be serviced. Another fault you are going to get, we have already talked about this dust. If you don't clean out this dust, what happens is you'll have what we call the blown electronics. The electronics will get blown. So you need to replace the blown electronic boards. We have the loose actuators, what we call the cylinders. Maybe the chair raises and it also drops again. It means your actuator cylinders are weak, so they need to be replaced. There is some looseness with where they are held. You need to tighten. There are areas of. We have what we call the hydraulic oil leakages. When you open this chair, you will find there are leakages within the chair. There is wetness within the chair. Where should you, what you need to do? You need to seal all the leakages within all the joints, tighten all the loose connections of the tubings, you tighten all the loose lock nuts. When you are checking where we have the solenoid valves, at the inside part of the solenoid valve, you are going to get what we call the lock nut. And these lock nuts, if they are loose, you will get that leakage of the hydraulic oil within the chair. And with the time, these lock nuts, they'll get loose due to vibrations, due to oil pressure. So these lock nuts, as an engineer, you need to tighten them. Every time you are servicing the chair, the lock nuts should be tightened. Are you using number 14, 15, 16, 17? You need to tighten the lock nuts. Replace any worn out tubings. These tubings, they are very hard to get worn out. But just in case you find one of your tubings is not working, you are being required to replace. We have a faulty sensor. The tubings are here. These are the batteries. These are the tubings also. These are the electrical wires. These are the electronics. This is the inside part of the chair. If the sensor cannot be tilted at the angle you want, it means that sensor is faulty. The earth leakage is very important. Recheck earth wire connections and tighten. Imagine your patient is on the table and then there is electrical leakage. What happens? That small micro leakage is very dangerous to the chair, very dangerous to the user, very dangerous to the patient. So always ensure the earth wire is always terminated and very tight and connected. The operating theater table, safety. And this safety mostly starts with the user. Handle the equipment with care. All the equipment must be handled with care. Don't clean the operating theater table with any bleaching detergent. Is it formaldehyde or what we call the formalin? Any bleaching detergent, because that will bring corrosion within our OTT. Don't splash the OTT with water or any other detergent. Switch off the OTT when not in use. And when we say switch off the OTT when not in use, remember that the power is connected and is charging the batteries. So here, it is very important here. You don't interfere with the chair when not in use. Don't drop down the remote for the user. Avoid sitting on the OTT when not in use. Very important here. Avoid overloading the OTT. Some of the patients, if they are more than 290 kilograms, you need to check the overloading of the operating theater table. Don't operate the operating theater table when not in use. Remember that this chair has various movements, up, down, sideways. So any students on attachment practicals will want to use the chair in this, will want to operate the chair. This is not allowed. Never handle the OTT if not trained. Very important. Post warnings, no unauthorized adjustments. Never lift the operating theater table unnecessarily. Don't put strappings on the operating theater table. Remember, these are all safety from the user side. We come to the technical safety. Don't allow air in the hydraulic system. Let's say you have replaced the tubing. You need to remove air within the line, the hydraulic system. You need to bleed out air. Always place the OTT on a level ground. Make sure the ground you are placing the OTT is very level. Never add more hydraulic fluid in the reservoir tank, because remember that this hydraulic oil circulates with the pressure. So what happens if you exceed the limit? It means it will come out from the tank. It will produce more leakages. So this level is very important. Never add or use no more oil to avoid issues of viscosity, lubrication, and contamination. Contamination and all these three mentioned here, you are being told never to use different oil apart from the given hydraulic fluid. Put or enclose the main PCB with a hardened nylon paper. You have seen the main PCB board, which is on top there. Sometimes you'll find that the covers are broken. And when the covers are broken and the user is trying to clean the chair, when they are cleaning, they are disinfecting that cover, down cover there. That detergent will flow to the electronics. But once it goes down through the electronics, this hardened nylon paper will protect your electronics. So this is very important for the engineer. Tighten all the loose screws, very important. Remove the corroded paint on the lower part of the OTT by use of a wire brush. Remember the wire brush, it is part of your tools you need to have. Why are we saying this? When you are servicing the OTT, the lower part of the chair is usually corroded. The paint has come out. The first thing you need to do, you need to use a wire brush. You need to seclude it out of the theater. Then you clean it. You clean out the paint you clean out the paint using the wire brush. Then you clean that part using the gauze. After that, you use what we call paint the lower part using the instant spray paint of the same color of the chair. Remember that you are using the instant spray paint because the doctor in the next 30 minutes would want to continue using the chair. So there is all within 1 hour. So that's why, as an engineer, you need to buy what we call the instant spray paint. Never leave the OTT covers open. This will avoid dust and it will avoid rodents entrance. Very important. If maybe you have not finished working on the internal parts of the chair and you want to leave to home, never leave the chair open because this is very dangerous, the rodents. When you spray the electronic contact cleaner, wait for 5 minutes until it dries up. If in case you have sprayed the electronic cleaner and you switch on the chair immediately, that will produce, will burn the electronics. So that's why you are being told that wait until the electronic contact cleaner gets dried. It's a fast dry contact cleaner. The end covers must be secured well. Ensure the locking screws are properly tightened. The OTT covers must be reassembled well and in order of their removal. This is very important, in order of their removal. You would want to decommission the operating theater table. So what is required? Disinfect the OTT either by use of alcohol 70% or specialized sterilization methods, or you are using the fumigation method, using the formalin, what we call the formaldehyde. Clean the OTT using warm soapy water to remove any possible debris and residues. Relocate the OTT to a secure store or a waiting area meant for the disposal. Remove the torn covers and burn them, whatever can get burnt. Remove the parts and store which can be reused. This is what we call cannibalization. Is it the PCB board? Is it the solenoid valves? Is it the tubings? Is it on and off switch, which is a push button switch? Is it a reservoir tank? Is it the circlips? Is it the locking pins? Is it the covers? Is it the locking screws? When you would want to decommission the chair, which part will it be able to help you? You can fix any of these parts to another working chair.
All right, thank you very much, Engineer Daniel, and thanks a lot to our audience for being very attentive. At this point, I'll take questions and comments so that our engineer can address them. If you have any comments, please do so.
Yeah, thank you for the opportunity, Janet. I'm happy for what Were has shared. I once handled a project and the most issues, my name is James Bondo. I used to work for Mindry and we used to have a project in Kenya where they had theater tables across the counties. So the major problem we had, where he emphasized that about cleaning, we are not in control of the cleaning of theaters. So we find that they use the cleaners in the morning. They'll splash water on the tables, and the boards could get damaged. So that's the emphasis we need to put: training the cleaners. And you may find the hospital is recruiting different cleaners every month, or the shift. There are people who cleaned the theater last week. They're not the same as the one cleaning this week. So you find we have a challenge on training of the cleaners. So if the hospital could manage that, they have specific people to clean a theater, would be better, and you'll have less breakdown or spoilage of theater tables or spilling of water on the tables or corroding them. So that's only my emphasis on that.
Thank you very much, James. That's a very insightful comment. I think the audience, everyone who's here, the engineers, technicians, have taken note. If you have any other questions, please, you can either raise your hand, I'll give you a chance to speak, or you can just type it in the chat. Questions based on what the engineer has said, maybe the experiences that you have had. You have one of the OTTs in your facility that is not working, you have a question on it, please bring them forward and the engineer will take those questions. Once again, thank you very much, James, for that comment.
Thank you so much, Janet, and thank you so much for the presentation. Elizabeth from Uganda. I have a small question. I have operating tables from Alvo, Serenada, but I noticed that they have an earthing cable connected to the base that is about 4 to 5 meters long, but I failed to find where to connect the other end of the cable. I'm not sure whether it goes to the machine or somewhere else. And I worry that at one point there may be current leakage. So maybe if you could let me know how I can utilize that part of it. Thank you.
Thank you very much, Elizabeth. I think a little bit of clarity. Are these new or you have already started using them?
We're already using them just about a year now.
All right, thanks. Engineer Daniel, I think you can take that one. She said they have some theater tables from Avo Serenata. I think if I got that correctly, there's a cable that is connected to the base, but she doesn't know where to connect the other end. So may you please advise on that?
Thank you, engineer, for that. Usually, the socket outlet, which is supplying the operating theater table, should be earthed. The earth wire should be connected to the socket outlet. Now, from that socket outlet, there is the coaxial cable. That coaxial cable, it carries 3 wires, electrical wires, to the OTT. And the 3rd wire is the earth wire. And that earth wire is coming from the socket outlet. So this earth wire should not be separately connected from the socket to the operating theater table. It must have been within the coaxial cable. Now, if you need to check from the building, that building, which is the theater, it must be earthed. It must be properly earthed. And you check from outside, is the connection for the earth well? Is the connection for the earth well terminated? So that when you come inside and you to the socket outlet, you make sure that earthing connection, it is connected from the MCB up to the socket outlet. Otherwise, we will not allow a separate earth wire to come to the OTT.
Thank you very much, Engineer Daniel. I don't know, Elizabeth, does that answer your question?
I think it does. But now I'm wondering why the cable was put there, because it has a port on the base that have the symbol for earthing or equipotential.
All right, I think the other thing that we can do is, Engineer Daniel, may you please help us in writing your either email or contact so that these people can also reach out to you.
Yes.
But in case of anything, maybe further clarifications, you can reach us through info@oxygenalliance.org for more details. But thank you very much. There's a question in the chat. I know there is a hand. Please don't drop the hand. I will take that hand. But then there's a question in the chat which is asking, at what point are we supposed to decommission the OTT? At what point do we suggest we're supposed to decommission the OTT? After that, then I will take the hand from Nizeyman. Thank you.
The meaning of decommissioning, it means you would not want to continue using the chair. And mostly this chair has the mechanical connections. As the mechanical connections failed, yes. Those mechanical connections, is it able to go up and down? The hydraulic system is not working completely. The tubings are not there. The tubings are worn out. The mechanical system is not able to work. That is the time you'll be able to say, I don't want to continue using this chair. Let me put away this chair. At that time, you are decommissioning the chair.
All right, thank you. Jean Sebshari, may you please unmute yourself and speak? You have your hand raised.
I'm Jean from DRC Congo, especially in Goma. And thank you, Daniel, for the presentation. It was very rich.
Thank you.
But as one of my colleagues have said, he asked the question, I said that most of the time, the experience we've got is that in the theater, you will see most of the equipment are being rusted because of the use of chlorine. And you say that as you do the cleaning, you are doing servicing, you need to use alcohol with a concentration of 70%. Is there no any other detergent that we can use instead of alcohol, or if there is no instead of using alcohol? And another problem is that suppose you are cleaning from in theater, within the theater, and maybe you are using alcohol in the along the side. There are some, the alcohol is it can catch fire easily. So there is no any other solution which can be used instead of alcohol. If maybe you have to do it inside the theater when you're not doing it outside. Is that the question I had? Thank you.
Yeah, when it comes to cleaning, like the endoscopy machines, when you're doing the disinfection of the probes and the rest, they have different types of agents that are non-alcoholic. I think some are good, they can be used. I haven't forgotten the names, but I think if they can consult the endoscopy team, they can assist in the hospital.
So there are other products. Do you think maybe you can use like is it a saffron or something like that?
Yes, as long as if you check the content, as long as they're not corrosive, you can use them.
Of the UV lamp, can we deploy the use of a UV lamp instead of the 70% alcohol? Because what I know, the 70% alcohol, which is isopropyl, it's a standard way of cleaning those theater tables.
Thank you very much. That is noted. I think you also had a question. May you please come in with your question?
All right. No, thank you very much. I think it was quite a precise and straightforward presentation. I think so. So mine is just to maybe seek clarity is that we get to.
Oh, okay, fine. So yes, certificates of attendance are there, but they are based on some conditions. Currently, we've been working on themes, and every theme normally has about 6 topics or 6 webinars. So if you attend 60% of those webinars, definitely you have a chance to get a certificate for all the topics that have been covered in that particular theme. I'll give an example. Currently, we're working on management of medical equipment. We have covered dialysis machines. We have covered endoscopy technology. That was a webinar we had 2 weeks ago. And now we're talking about these OTTs. So if it happens, let's say out of the topics that we've had in this quarter, and then you watched, let's say you attended 5 or 4 webinars, you might be eligible to receive a certificate from the Oxygen Alliance that you attended those trainings. And also, just to be explicit, we look at how active you were, how long did you stay in the core. Those are the things that would say, I think somebody learned something and then they need to have a certificate out of their time and their effort to join. I think that answers your question. So I'm seeing a comment or a question. Will you guys organize a hands-on maybe sometime? For now, we cannot say, but we have taken note of that. I think a lot of people would want to do the hands-on. So when we get a chance, we know we have people from across the region. Others are from Kenya, Rwanda, Malawi, Nigeria. So we'll see if we have the resources to reach out to you with the hands-on experience or hands-on training. But for now, I'd like to say thank you to our audience, everyone who joined. Thank you very much. And also thanks to our Engineer Daniel. You have been with us in the preparations. To our audience, everyone who joined, thank you very much. And bye from the Oxygen Alliance. Bye for now. See you next time.
If you have comments and/or questions, drop them in the comment section below or write to us info@oxygenalliance.org. Remember to like our videos, subscribe to our channel, and hit the notification bell.